In this video, we're going to go ahead and take a look at the period of sine and cosine functions. So what is the period? The period is how long does the function go before it repeats itself. So why is it that this function repeats itself? So we've seen the graph already. We know that it goes through a hill, then a valley, and that is one complete period. So what is the horizontal distance now for it to go ahead and go through that entire hill and that entire valley? Because after that point, it repeats itself. So what is the horizontal distance that it goes through one entire one of those? That's going to be the period. Then it goes through it again, and it's going to go through it in that exact same amount of time or exact same distance. That's going to be the period again, and then again, and it's going to keep doing that on and on forever and ever. So in these problems, pay attention to where you're starting at. Are they starting you on the midline? If they are, you need to go through a hill and a valley. Or you can go through a valley and then a hill. So those are for the midline, starting on the midline. So you can see starting on the midline, you go through a hill and a valley. You need to make sure you cover both of those. What if they start you on the maximum? If they start you on the top, then you need to go all the way to the valley and then end on the maximum. So that's going to be one period as well. That'll work as the period as well. So if you're starting on the top, you need to end on the top. Similarly, if you start on the bottom of the valley, you need to go all the way up to the top, and then you'll end on the bottom. And that midline is right there in the middle, but the period's going to be the horizontal distance from the bottom there to the other bottom on the other side. Actually, it'd probably be better just to put this right there. Same thing with this one. So what are we starting on? How much distance? Remember, we want to figure out what's that horizontal distance this time that we're going. So this one, they're starting us on the top. So we want to find that horizontal distance. Oops, sorry about that. We want to find that horizontal distance to the other top here. We're going to figure out what is that distance there. Well, they gave us right here the bottom part. That's actually right in the middle. So what is the horizontal distance there? We're going to look at the x values because that's a horizontal axis, right? So negative 1.7 minus negative 5 is going to be negative 1.7 plus 5. Negative 1.7 plus 5 is going to be, I think, 3.3. Makes sense. So 3.3 is half of the distance that we need to go. So you would add another 3.3 to it to get 6.6 as the period. What if they'd given us a point on the midline instead? If they gave us this value here, that's only a quarter of the way. You would need to go through another 3/4. So just pay attention to what's given here. So we're going from the top to the other top. We have this halfway point because it gave us the bottom. Same thing here. From top to top, we have the halfway point. You're going to go through the exact same thing there. What about here? Now we have the midline, right? So we have one on the midline. We need to go through a valley and a hill before we get to the end. So we have, once again, we have the halfway point. So let's find that horizontal distance. So look at the x values, 3.6, negative 4.5. So 3.6 minus negative 4.5. 3.6 plus 4.5. Which is 7, which is 8.1. So 8.1 is our halfway. So double that for 16.2 will be the period. here you can see that we're going to go through the hill and then the valley and end right here. So just pay attention to those little details, right? Okay, now we're starting on the midline. So we want to go through, here's a valley. Here's our hill. And we want to end on the midline, which would be like over here, right? So we're going to be finding that horizontal distance there. Now, this right here is the halfway point. Put it in green. That's the halfway point. We have halfway to that halfway point, right? The 4.5 and the 1.25, if we subtract those, 4.75 minus 1.25 is going to be 3.5. So that 3.5 represents just this distance right here. So that's only a quarter of it. We still have an additional 3.5 plus 3.5. Plus 3.5 again. So we have that times 4. Which is 12 plus 2 is 14. Same thing here. Just this time they're starting us on the bottom and going to the midline. You'll realize we got to go from the bottom to the other bottom, right? And so this is the halfway point. So we're only given a quarter of the way. So really just like the other one, just think about where you're at geometrically, try to figure out those lengths.